Hello everyone, the topic today is permutations, combinations and the binomial theorem, and therefore it is divided in two parts. The first part is permutations and combinations, and the second part is the binomial theorem. And let's start the lesson. The first exercise is permutations. How many 5-digit permutations can be formed using the digits 1, 2, 3, 4, and 5? Under permutations, the order of the digits is important. For example, the combination 1 and 2 is different with the combination 2, 1. Or, for example, if I have 5 digits, then 2, 3, 4, 5, 1 is different from 1, 2, 3, 5, 4. So we use the formula you see on the screen, n times n minus 1 times n minus k plus 1, or as a fraction n factorial over n minus k bracket factorial. So how many 5-digit permutation can be formed using these digits 1, 2, 3, 4, 5? So we need to find 5 factorial. 5 factorial is 5 times 4 times 3 times 2 times 1. And this gives us the answer of 120 permutations. The second example is how many 3-digit permutations can be formed from digits 1, 2, 3, 4, 5. In this case, we need to find the P 5, 3, because I want 3 digits out of 5 numbers. In this case, we need to find the 5 times the 4 times the 3. So it is 20 times 3, so this is 60 permutations. Another example of looking at this is 3 digits. The number needs to have 3 digits. How many possibilities for the first digit? 5. How many possibilities for the second digit? 4, because I don't want to repeat the first selected. And how many possibilities for the third digit? 3. So we times these options and we found 60. The numbers cannot be repeated. That is why you have 5 times 4 times 3. So it's 60 permutations. And let's move to the next example. How many 5-digit combinations can be selected from the digits 1, 2, 3, 4, 5, 6, 7? Combinations, the order does not matter. For example, 5 digits, let's take 2 digits. 1, 2 is the same as 2, 1. So it's not, the 2, 1 is not, doesn't count as a second combination. So we take only the first. This is the difference between combinations and permutations. So in this case, to find the combinations, we use the formula that is shown here. So the C So we're looking to find 7, 5, because in total we have 7 digits, 7 options, and we want to have 5 digits. So the n is 7, the k is 5, and we use this fraction, which is n factorial over n minus k bracket factorial times k factorial. So the combinations that we can have, we can make 5-digit combinations out of 7 numbers is 7 factorial over 7 minus 5 is 2 factorial times the 5 factorial. 7 factorial is the same as 7 times 6 times 5 factorial. And the 5 factorial cancel out. So we do 7 times 6 divided by 2. So this is 21 combinations. And let's go to this example. In how many ways can the 12 letters A, B, C, D, E, F, G, H, I, J, K, L be arranged? So here we are looking for different arrangements. So it have to be permutations. They are permutations because the order matters. So we need to find the 12 letters be arranged, so we need to find 12 factorial. And the answer 12 factorial is 479001600 arrangements. So this is the number of arrangements of these 12 letters. How many 6-letter arrangements can be made using these letters? So here we need to have only 6 digits. And we have a total of 12 letters. So obviously here we need to find the P 12 6, because the first letter can have 12 options for the first digit. The second is 11, the third is 10, the next one is 9, the next one is 8, and the next one is 7. So this is 12 times 11 times 10 times 9 times 8 times 7 arrangements, which give us the number 665,280. Then one of the letter cannot be repeated. That's why it's 12 times 11 times 10 times 9 times 8 times 7. This is the options that we have. And let's move to the next example. How many 7-letter arrangements beginning with C can be made using the letters? A, B, C, D. So there are 12 letters in total. So we need to have 7 letters out of 12, but the first letter need to be constant, C. So we need to have the C first letter. But how many options we have for the second digit are 11 options. How many options we have for the third digit? 10 options, because I cannot select the same letter. How many options we have for the fourth digit? 9. How many options for the following digit? 8. For the following digit, 7 options. And for the following one is 6 options. If I multiply this, the number of options for each digit, then I need to have 11 times 10 times 9 times 8 times 7 times 6. So it's 11 times 10 times 9 times 8 times 7 times 6, and this gives us the value of 3, 3, 2, 6, 40. And the next example is how many ways can 6 letters be selected from. Here we are looking for combinations of letters, 6 letters out of 12, so we need to find the C12 out of 6. Using the formula of combinations, this is 12 factorial over 6 factorial times 6 factorial, which gives us the value of the 12 factorial can be written as 12 times 11 times 10 times 9 times 6 factorial over 6 factorial times 6 factorial. The 6 factorial cancel out, and then doing the calculations give us 924 combinations. And now I'm going to do the binomial theorem. For the binomial theorem, we use this expansion, the bracket to the power of n. A plus b to the power of n is equivalent to the a to the power of n plus c n1, a to the power of n minus 1 times then b, and so on. It has a pattern. So using the above expansion, we can expand the brackets p plus q to the power of 10. So in this case, we have p to the power of 10 plus cn1. So it have to be the 10, 1, p to the power of 9 q plus 10, 2, p to the power of 8 times q to the power of 2, and so on. And we follow this pattern until we found the last term, which is q to the power of 10. What we can do next is to find the value of the brackets, which are the combinations, 10, 1. So the first term is p to the power of 10. You can also use the calculator to find the 10, 1, or you can use the formula we already did before. So using the calculator, you press 10, shift division 1, and this gives you 10 times the p to the power of 9 q plus 10 shift division 2 give us a value of 45 p to the power of 8 q square. In the same way, I follow this formula and then I write the terms. And this is the expansion. The next one, it has two terms, x plus 1 over x squared to the power of 9. Following exactly the same formula, we have x to the power of 9 plus 9, 1, x to the power of 8, 1 over x squared to the power of 2, power of 1, and this expansion looks like this one. The next step is to simplify the terms and the doing calculations. So this is x to the power of 9 this is 9 x to the power of 8 over x squared give us x to the power of 6. Then 9, 2 is 36 times x to the power of 7 over x to the power of 4 give us x to the power of 3 plus dot 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 plus 1 over x to the power of 18. This is the last term of the expansion, but we need to follow all of the terms and not simplify the terms using the indices rules. This is the binomial expansion. This is the lesson today. If you like the lesson, don't forget to subscribe. Thank you for watching.